All right, Algebra 2 folks, it is Tuesday. Hopefully the turkey sleepiness is worn off and you are able to really kick butt today on our day 2 packet. We're looking at more complicated radical equations that we've got to solve, okay? And so that's basically what we're focusing on, okay? You'll notice that to solve radical equations here, step 1 is to isolate the term that contains the radical. Make sure that it's all by itself on one side of the equal sign. Then raise both sides of the equation to whatever is the power of the radical. And then to solve, completely get the remaining variable all by itself. And then for sure you got to check all the solutions because there might be an extraneous, which means that possibly there's no solution, okay? So let's get after it. Here we go, all right? So number 1, show all your work, check for solutions. Remember, you're looking for extraneous, so these first couple might be pretty easy. Number 1, 2x raised to the 4th equals 16, all right? So the term over here, 2x, is raised to the 4th, so if I fourth root that and fourth root the right side, so I'm fourth rooting both sides. So the fourth root undoes the fourth power so that I just have 2x. And the fourth root, remember this is a fourth. Fourth root of 16, what times what times what times what makes 16? Well, that's a 2. And remember, since we fourth rooted both sides, we get that plus minus 2. Okay? So now I divide by 2. And so x equals a positive 2 divided by 2 is 1. And a negative 2 divided by 2 is a negative 1. So we get a plus minus 1. Now let's check our work in the original. And so 2 times a positive 1 raised to the 4th. Does that equal 16? And does 2 times a negative 1 raised to the 4th equals 16? All right, so the top one, 2 times 1 is 2. 2 to the 4th, sure enough, 2 times 2 times 2 times 2 makes 16. 2 times a negative 1 is negative 2. So negative 2 raised to the 4th power. All right, negative 2 times negative 2 is a positive 4. Times another negative 2 is a negative 8. Times another negative 2, yes, is a positive 16. So both of them check. So a positive 1 and a negative 1 is the solution to that. Okay? All right, moving on. Number 2. 2x to the 4th equals 162. So first step is to divide both sides by 2. So x to the 4th equals 81. All right, so now we fourth root both sides. So x equals, once again, plus minus symbol since we fourth rooted both sides. 2 times 2 times 2 times 2 is only 16, so it's not 2. Well, 3. 3 times 3 is 9, times 3 is 27, times a fourth 3, so sure enough, this is a plus minus 3. All right, so let's make sure that it works when we put it back into the original. So 2 times a 3 raised to the 4th, does that equal 162? And does 2 times a negative 3 raised to the 4th also equal 162? All right, so do your exponent first. So 3 raised to the 4th, 3 times 3 times 3 times 3 is 81 times 2 then. Sure enough, 162, so a positive 3 works. Negative 3 raised to the 4th, so negative 3 times negative 3 times negative 3 times negative 3 also is an 81, positive, times the 2 also makes 162, so they both work. So a positive 3 and a negative 3 are the two solutions for that one. Okay? Moving on, number 3. Got plenty of space here, it looks like. All right. The square root of x squared minus 3 equals x minus 3. So the first thing I'm going to do is I'm going to square both sides. That gets rid of my square root on the left side. So I simply have x squared minus 3. And then on the right side, x minus 3 times x minus 3, those two binomials multiplied together actually make x squared minus 3x minus 3x would make a minus 6x for the middle term, and then negative 3 times a negative 3 is a positive 9. Okay? So if you'll notice something, we've got x squared minus 3 equals x squared minus 6x plus 9. So since there's x squareds on both sides, like if I were to move this x squared over to the other side, I'd subtract it, right? And I'd bring it over to this side by subtracting it, and they undo each other. So whenever you have a positive x squared and a positive x squared on the opposite sides of the equal sign, they cancel each other out. So then I really have a negative 3 equals a negative 6x plus 9. Move the 9 by subtraction over to this side. Still have a negative 6x on the right equals now a negative 12. Divide by negative 6, and you get x equals a positive 2. Negative 12 divided by negative 6 is a positive 2. Okay? So let's check that back into the original. The original is a big old square root. And we've got x squared, so I'm going to go 2. That's going in place of the x squared minus 3 equals, on the right-hand side, we have x minus 3, so I'm going to put 2 minus 3. All right, so as we punch this bad boy out, 2 squared is 4, 4 minus 3 is 1, so the square root of 1, which is 1, right, equals 2 minus 3. Well, 2 minus 3 is a negative 1. Well, a 1 does not equal a negative 1, all right? So this x does not equal 2, so there's no solution for this problem. Okay? A whopping no solution for number 3. So far, these first 3 problems have been pretty easy, not too, difficult, not too radical. How do you like that play on words there, folks? All right, here is number 4. Square root of 2x plus 5 equals x plus 1. So if we square the left-hand side and then square the right-hand side, when I square the right-hand side, I'm going to put that x plus 1 into parentheses because I'm squaring that whole side. So the square undoes the square root over here, so we're left with 2x plus 5. Now, an x plus 1 squared means that you have 2 of those parentheses side by side, okay? So you have to FOIL that. You get x squared, a positive x, and another positive x makes 2x, and then 1 times 1 makes 1. So now you have 2x plus 5 equals x squared plus 2x plus 1. And so once again, notice this time we have a 2x on the left-hand side and a 2x on the right-hand side. So if I were to move one of them to the other side by subtracting, you'll notice that they both get canceled out. So really what we have here is now just 5 equals x squared plus 1. So move the 1 by subtraction. X squared equals 4. Square root both sides, and you'll find out that x equals, remember, when you square root both sides, you get a plus minus 2. So we need to see if a positive 2 and a negative 2 works, all right? So in the original, I've got a square root of 2. I'm going to put a positive 2 right next to it, multiplied, plus 5. That's all under the square root on the left, equals a 2 plus 1, because I'm putting 2 in place of the x, okay? All right, let's quickly do that. So 2 times 2 is 4. 4 plus 5 is 9. The square root of 9 is 3. Is 3 equal to 2 plus 1? Yes, that works. So I know that a positive 2 works. All right, let's try a negative 2. So 2 times a negative 2 plus 5 underneath of the square root equals, on the right-hand side, a negative 2 plus 1. Okay? So 2 times a negative 2 is negative 4. Negative 4 plus 5 is 1. So we have the square root of 1. Well, we know that that's equal to 1. Square root of 1 equals 1. Does 1 equal a negative 2 plus 1 here? Well, that equals a negative 1. 1 does not equal a negative 1, so it does not work for the negative 1. Okay, so x only equals a positive 2 then. Just a positive 2. The negative 2, it does not work. Okay? All right. That was a little more difficult. Number 5. All right. Square root of x minus 3 on the left equals 1 minus the square root of x. So notice we've got radical signs on both sides of the equal sign. So let's square both sides. Once again, when I'm squaring the right side, I'm putting a parentheses around that. Okay? Because I'm squaring the whole side. So the left side, the square undoes the square root, so you're simply left with x minus 3 on the left. Okay? But now on the right-hand side, that's a binomial squared. So that means you have 2 of those. 1 minus square roots of x. Okay? So 1 times 1 is 1. 1 times the square root of x is the square root of x. A negative square root of x times a 1, all right, is a negative 1 square root of x. So we have, in essence, notice, you have 1 times a negative and then a negative times a 1. So in other words, you've got a negative 2 square root of x. Because a negative 1 square root of x and another negative 1 square root of x makes a negative 2 square root of x. And then the last 2 terms. All right, so here we go. Negative times negative will be positive. Square root of x times square root of x is going to be an x. And remember, it's positive. Okay? So there's where we're at this point. Okay? So I think what I want to do is let's move this 1 over to this side by subtraction. So now I have x minus 4 on the left equals a negative 2 square roots of x plus x. Okay? And then at this point, if I notice that I have a positive x and a positive x, so if I were to subtract this x to move it over to this side, notice, cancels out there, cancels out there. So now I'm down to negative 4 equals a negative 2 square root of x. Okay, so divide now by negative 2. So finally we've got the square root of x by itself equals negative 4 divided by negative 2 is a positive 2. Square both sides to get rid of that square root symbol, right? And so x is now by itself, and 2 squared is 4. So x equals 4, okay? And let's make sure that that actually works, plugging back into the original. So square root of x minus 3, so 4 minus 3, equals 1 minus a square root of, and we're putting 4 in for x, okay? So here on the left side, the square root of 4 minus 3 is 4 minus 3 is 1, so the square root of 1, well, we know that that's just a 1, right? Equals Over here, the square root of 4 is a 2. So really what we have is 1 minus 2. Well, 1 minus 2 is a negative 1. 1 on the left does not equal a negative 1 on the right. So this does not work. All right? It's not equal to 4, so it's no solution since we don't have any other values. All right? No solution for that bad boy. Okay? All right? And the sixth one. All right. Square root of 3x minus 2 minus a square root of 2x minus 3 equals 1. So I think we would like to get our square roots on the opposite sides of the equal sign. So that then I can, when I square root both sides, we get stuff to, the radicals to get eliminated somewhat. So if I move this second square root, negative square root of 2x plus minus 3, I'm going to add it then. And I'm going to add it over here. Okay? So now what I have is simply the square root of 3x minus 2 on the left equals, okay, 1 plus square root of 2x minus 3. Okay? So let's get this square root to get eliminated. So in other words, I'm going to square both sides, which means I'm putting a parentheses around this because this is 1 plus that. And I'm squaring both sides, okay? So the square undoes the square root. So the left side is simply 3x minus 2. The right-hand side, so I've got two of those binomials, okay, being multiplied. So if I were to put another one right there, 1 plus the square root of 2x minus 3, all right? 1 times 1 is 1. 1 times a square root of 2x minus 3 is a square root of 2x minus 3. All right? Then this square root of 2x minus 3 times that 1 is another square root of 2x minus 3. And then a square root of 2x minus 3 times another square root of 2x minus 3. Okay? Square root times square root undoes the square root, and you're simply left with a 2x minus 3. Okay? So, what these two right here make are two of those. So, in essence, the left side is still the same, 3x minus 2 equals 1. And I'm going to make this as 2 of these. 2 square roots of 2x minus 3 plus the 2x. And I guess that minus 3, I should combine it with the 1, all right, to really make that negative 3 combines with this 1 to make minus 2. Okay, so now I'm going to erase that. Okay? All right. So at this point, I guess I need to get everything away from the square root. Okay? Maybe if I add, okay, let's think this through. A negative 2, sure enough, a negative 2 on the left-hand side, a negative 2 on the right-hand side. Undo each other, okay? And then if I bring this 2x over to the left side by subtraction, now I just have an x, 3x minus 2x, right? X equals 2 square root of 2x minus 3. All right, so we're going to get the radical to get isolated. To do that, I'm going to divide by 2. No, let's not do that. Let's square both sides, okay? So if I square this left side, that makes x squared. And when I square that right side, what in the hairy deal does that make, right? That's probably what you're wondering. I don't even have a whole lot of space left. So x squared equals, so this square is going to square the 2 to make 4. And then it's going to cause this square root to disappear. So then I have a 2x minus 3, all right? Right next to that 4. Okay? So that's going to make 8x minus 12. So x squared equals 8x minus 12. Okay? X squared equals 8x minus 12. Okay? So then if I move everything to one side over to this to make a trinomial, I get x squared minus 8x plus 12 equals 0. And if I factor it, okay, don't really have a whole lot of room here. Let's see if I can find a blank piece of paper. How about a Post-it note? Okay. So if I make 2 sets of parentheses, x and x, 1 and 12, 2 and 6, probably 2 and 6. They multiply to be positive, so they have the same sign. They add to be negative 8x, so x minus 2, x minus 6 equals 0. So then that means that x will equal a positive 2, and x will equal a positive 6. Okay? And so if you proceed to try and check that, okay, into the original, here's how that looks. First, the 2. If I go square root of 3 times 2 minus 2, and then minus another square root of 2 times 2 minus 3. Does that equal a 1? Okay, so let's do some math. 3 times 2 is 6. 6 minus 2 is 4. So the square root of 4, that's going to be a 2. Okay? And 2 times 2 is 4. 4 minus 3 is 1. Minus the square root of 1. And the square root of 1 is 1. So 2 minus 1, does 2 minus 1 equal 1? Yes, it does. So the 2 works. Okay? All right, let's try the 6. I'll do that one in red. Square root of 3 times 6 minus 2 minus another square root of 2 times 6. Remember, I'm putting 6 in place of the x. Minus 3. Does that equal 1? So 3 times 6 is 18, minus 2 is 16. The square root of 16, you and I know that's 4. 2 times 6 is 12. 12 minus 3 is 9. This is going to be minus the square root of 9, and the square root of 9 is 3. Is 4 minus 3 equal to 1? Yes, it is. So both of the answers, x equals 2 and x equals 6, can be boxed in. You're going to have to write smaller on some of these, I suppose, than what I just did, since I had to use a Post-it note. Okay? Anywho, that is day 2, a little bit more challenging radicals equations that we have to solve. And just remember that when you solve radical equations, all right, that you have to check your answers back into the original, all right? Sure do love you guys. If you're at home, miss you. If you're quarantined or sick or whatever. But hurry back and get to class and so forth. But we miss y'all, and peace out. That's it. Do the homework.